Hello everyone, this is Heading 10. In this video, let's learn Chapter 6.3, Double Angle Power Reducing and Half Angle Formulas. First, we will learn the double angle formula. What is the double angle? For the trig function, double angle, we have learned that, for example, we have learned sine alpha. This is the single angle, just the alpha. And the double angle means sine 2 alpha. And what's the sine 2 alpha equals? We have learned that the sine formula, the sine 2 alpha is alpha plus alpha, and use the sine formula. That's the sine alpha times cosine alpha. This alpha is this alpha, and this alpha is this cosine alpha. And the plus cosine alpha. This alpha is the first alpha times sine alpha. So this term and this term, they are the same. That means this one equals 2 times sine alpha times cosine alpha. So this is the sine 2 alpha. Yeah, how about the cosine alpha? 2 alpha. So cosine 2 alpha. 2 alpha, use the cosine formula. This one equals cosine alpha plus alpha equals cosine alpha times, cosine alpha again. And then here is minus sine alpha times sine alpha. So cosine alpha, this is cosine alpha squared. This is sine alpha squared. This one equals cosine squared, alpha squared minus sine alpha squared. And look at this. This term, we have learned the Pythagorean Theorem. That means, put it here. That means sine alpha squared plus cosine alpha squared equals 1. That means this term can be replaced by 1 minus sine alpha squared. So for example, if it replaced by the 1 minus sine alpha squared, so this term is this. So minus the following term is sine alpha squared. That means 1 minus 2 times sine alpha squared. So cosine 2 alpha equals this term, also equals this. How about I replace this term to 1 minus cosine alpha squared? Let's try. So keep the first term, which is cosine alpha squared, minus, I put a parenthesis here, 1 minus cosine alpha squared. So distribute the negative sign, get rid of the parentheses. That means minus 1 and plus cosine alpha squared. That means 2 cosine alpha squared minus 1. That means cosine 2 alpha has 3 kind of expression. First one, second one, third one. These 3 expressions, they are equal. How about the tangent? This is a cosine, sine, cosine. Let me highlight them. I can't highlight them, so just box them. Okay, how about the tangent? 2 alpha. 2 alpha. We have learned tangent formula. That is tangent. This is alpha plus alpha equals tangent the first alpha plus second alpha over 1 minus tangent alpha times tangent alpha. So this one equals 2 times tangent alpha, 1 minus tangent alpha squared, because we have 2 tangent alpha. Okay, so these are the double angle formulas. So here they just give you the result. They didn't tell you how they find the double angle formulas. So you can memorize them, or you go back to see how we find these double angle formulas. Use the procedures to help you memorize them better. Okay, so these are the double angle formulas. Let's use the double angle formulas to compute some questions. The first one, 2 times cosine 15 degrees minus 1. So it's nothing about cosine 2 alpha or cosine 2 theta equals some expression we just talked about a minute ago. But look at this term and this term. They are the same because we just assume theta equals 15 degrees. So that equals cosine 2 theta. That means equals cosine 2 times theta, which is 15 degrees. That's cosine 30 degrees. That is square root 3 over 2. How about the second one? Second example. So this is about tangent. So 2 times tangent theta over 1 minus tangent theta squared. So this is 2 times tangent 15 minus, divided by 1 minus tangent 15 squared. So that's tangent 2 times 15 degrees. That's tangent 30 degrees. So what is that? That's square root 3 over 3. Okay, let's move on to see next example. Given that sine theta equals 2 over 3 for theta in quadrant 2. So if they provide us the theta in quadrant 2, I just draw an xy plane. Fine, this is in second quadrant. So they ask us to find the sine 2 theta. Just use the formula. That is sine 2 theta equals 2 times sine theta times cosine theta. But we don't know sine theta. Oh, we know sine theta here. We don't know cosine theta. So it's given that sine theta is 2 over 3. And in the second quadrant, so sine theta equals 2 over 3. And also we have learned sine theta equals y over r. That means we can assume that y equals 2, r equals 3. And how about the y? How about the x? X equals plus or minus square root of r squared minus y squared. So this is plus or minus 3 squared minus 2 squared. That's 9 minus 4. That's square root of 5. So it's positive or negative. So look, it's in the second quadrant. So all the x value, they are negative. So here is negative. Okay, so we know the x, y, and r. So can we find cosine theta? Cosine theta equals x over r. So it's negative square root of 5 over r is 3. So if we have the cosine theta, we can find the value of sine 2 theta. 2 times sine theta is 2 over 3 times cosine theta is negative square root of 5 over 3. Do the algebra. Let's see, what is that? So nothing can be cancelled. So 3 times 3 is 9. Bottom one is 9. So 2 times 2 is 4. 4 times square root of 5. Remember here, there is a negative sign here. So pull out the negative sign in the front. So let's move on to see next example. Oh, next part, number B, cosine 2 theta. So can we have learned that cosine 2 theta has 3 formulas. The first one is cosine theta squared minus sine theta squared. So we have the cosine theta and sine theta here. We can plug it in the expression, or we just use 1 minus 2 times sine theta squared, because this is another expression. Just plug in one unknown term, that is 1 minus 2 times. So sine theta squared, sine theta is 2 over 3. So 2 over 3 squared is 4 over 9. And then 1 minus, so 8 over 9, because 2 times 4 is 8. Make it clear. So that's 1 over 9. This is the answer for number B. Let's see. Tangent 2 theta. So this one, you can use the formula that's the complex one. That is 2 times tangent theta divided by 1 minus tangent theta squared. You can use this, but can you find the shortcut or the easiest way? Yes, we can find the tangent 2 theta by using sine 2 theta over cosine 2 theta. So we find this cosine and sine 2 theta here. That means, sorry. Sine 2 theta is on the top. So sine 2 theta is negative 4 times square root of 5 over 9, and divided by 1 over 9. That means divided by 1 over 9 means times the reciprocal of 1 over 9. That's means times 9. I skipped some steps, so you can continue to write down the steps here, because I have no space here. So this one equals negative 4 times square root of 5. Okay, let's move on to verify this expression, this identity. Sine 3x equals 3 times x minus 4 times sine x cubed. I made a typo here, so here is cubed. So which side are you going to start? I prefer the left-hand side all the time. And also look at here, in the sign, that's 3x. That means is complex term. And here is sine x, even it has cubed, but still 3x is more complex than the single x. So let's start from the left-hand side. So left-hand side equals, that's sine 3x equals, so I just want to make it to the single x term. So sine 3x equals 2x plus 1x. And then use the sine formula, the sine 2x times cosine x plus cosine 2x times sine x. And also it still has the 2x term. Use the double angle formula to get rid of the 2x. So sine 2x, what is that? That's 2 times sine x cosine x. This is sine 2x, and don't forget you have another cosine x, plus cosine 2x. you can choose any of them. So if you want to choose sine, oh, sorry. So if you want to choose cosine x squared minus sine x squared is totally fine, times sine x. And this one is 2 times sine x times cosine x squared plus, so distribute this sine x. So cosine x squared times sine x minus sine x cubed. Oh, it's almost there because we have cubed the term. Okay. So look, cosine x squared sine x, cosine x squared plus sine x times sine x. So these two terms the same. So 2 plus 1, that's 3. 3 times sine x times cosine x squared minus sine x cubed. And look at the right hand side. It doesn't have cosine term. So that means I need to convert this cosine to the sine. Use Pythagorean Theorem. That's 3 times sine x. And then use parentheses 1 minus sine x squared minus sine x cubed. And distribute the 3 sine x. So 3 times sine x minus 3 times sine x cubed, because this is sine x times sine x squared. That means 3, the power is 3. So because here power is 1, 1 plus 2 is 3. And then minus sine x cubed. And this one is 3 times sine x minus 4 times sine x cubed. Okay, we complete the evaluation. That means left hand side equals right hand side. We proved that. Okay, let's move on to see next one. This example, cosine 2 times sine inverse sine 1 over 5. Let's figure out what's the meaning of this. We have learned the inverse means angle. So we let's assume this part, this alpha. So let sine, the inverse sine 1 over 5 is alpha. That means we are looking for cosine 2 alpha. So if we are looking for cosine 2 alpha, we have several formulas to express this. So we have 1 minus 2 times sine alpha squared. Why I choose this, I will talk to you later. Okay, so here we have sine, the inverse sine 1 over 5 is alpha. So we have learned for the sine inverse, we only choose the angle from here to here. This is positive, it's in the first quadrant. So actually, there's no need to tell you where is the alpha. That's it. When we see this, we better to just say, just identify where is the alpha. Okay, alpha is here, and sine alpha equals 1 over 5, right? Just convert it to the regular form. So if we have the sine alpha equals 1 over 5, just plug in the expression here. We don't need to find the cosine alpha. We just need to find the sine alpha and then find the cosine 2 alpha. So the question is asking about the cosine 2 alpha. That means I waste the space here. I had better write more information here. It doesn't matter. So if I write it down here, okay, 1 minus 2 times sine alpha squared. That means 1 over 5 squared. That means 1 minus 1 over 5 squared is 1 over 25. That's 2 over 25. That's 23/25. So this is the final answer for this question. Okay, let's continue to see the power reducing formula. So in previous part, we learned the double angle formula. Here is power reducing formula. How we got all of these formulas. So just use one double angle formula, we find all of these power reducing formula. So do you still remember cosine 2? Here is theta, so we use theta. 2 theta, that equals, we have three kind of different expressions. So if I choose one minus sine, 2 sine, 2 times sine theta squared. So if I'm looking for sine theta squared, I just isolate this term. Let me try if I can highlight. No, I still can't. No. Okay, so I want to find the expression of a sine theta squared. That means 1 minus this term equals this. And this term equals 1 minus cosine 2 of theta. That means 2 times sine theta squared equals 1 minus cosine 2 theta. And then divided by 2 both sides. I got sine theta squared equals 1 minus cosine 2 theta over 2. Are they the same? Yes. So we use the double angle formula, find the power reducing formula. And how about the second term? Second term, do you still remember cosine 2 theta, cosine 2 theta equals 2 times cosine theta squared minus 1. Okay, so if I isolate the cosine theta squared, that means plus 1 both sides. So I have 2 times cosine theta squared equals cosine 2 theta plus 1. I want to get single term, that means divide by 2. So is that the second term? That's cosine 2 theta plus 1. 1 plus cosine 2 theta or cosine 2 theta plus 1 is the same. So this term divided by 2 because we find it from the double angle formula. And the tangent theta, we don't need to make that complex because we just find out sine theta squared and cosine theta squared. Just use this term, first term, divided by second term. So the two canceled out. So this part is on the top. Second part is in the bottom. So 1 minus cosine 2 theta over 1 plus cosine 2 theta. Okay, let's use the power reducing formula to find some, to solve some problems. The first example, write sine x to the fourth plus cosine x cubed, x squared in terms of first power of cosine. That means we need to get rid of the 4 and get rid of 2. So let's see. We just learned squared, and squared. We haven't learned fourth power. That means we can do that step by step. So this term, I just skip it, copy down the question. This term equals sine squared x squared because they have the same base. So 2 times 2 is 4. That means a squared cubed equals a 2 times 3 equals a to the 6th power because only have one base. If I have two base, a times a squared plus a cubed equals, since two base, the same base is 2 plus 3. That's a to the 5th power. So this is 1 base. That means 2 times 2 is 4. So make it into the smaller or lower power of the sign. And then cosine x squared. That means I can use the power reducing formula. That's 1 plus cosine 2x. And then inside the squared, I can use a power reducing formula. That's 1 minus cosine 2x squared plus, bring down the second term, 1 plus cosine 2x. And then this is squared. I just square the terms. Bottom one is 4. The top is 1 minus cosine 2x squared. Do I have enough space? I think so. So let me erase this to make it smaller. Okay. 4. 1 minus cosine 2x squared. 1 plus cosine 2x. Then this term equals 1 minus 2 times cosine 2x plus cosine 2x squared plus, so if I want to combine them together, these two terms, they need to have same denominator. That means this term I can times 2 to bottom and top. That means bottom is 4. And then the top is distribute the 2 in these two terms. That's 2 plus 2 times cosine 2x. And then 4 in the bottom, and combine the like terms together. So we have minus 2 times cosine 2x plus 2 times 2x. That means these two cancel out. Two terms cancel out. 1 plus 2, that's 3. And then second term is plus cosine squared 2x. So it still have a squared here. So this one, I can also use the power reducing formula. So that is 2 in the bottom, 1 plus cosine 4x. Because here need to be 2 theta. Theta here is 2x. So here is 4x. So I need to simplify this term. So the bottom is 4. The top 3 and this term, I need to combine them. I need to have the same denominator. The lowest common denominator is 6. So the 3 need to, oh, sorry, no. The lowest common denominator is 2. Because 3 is a number, it's not a fraction. It doesn't have a denominator. So 2. The bottom need to be 6. So 6 plus 1 plus cosine 4x. So divided by 4 means times 1/4. So that means times 1/4, just step by step. So 6 plus 1 is 7 plus cosine 4x. So divided by 2 and multiply by 1/4. So 2 times 4 is 8. So 8, 7 plus cosine 4x. That equals 7 over 8 plus cosine 4x over 8. So we like to have the form that, let me write it down, is y equals a times cosine bx minus c plus d. We like to have this. So d is a vertical shift. So we write it down. So 7 over 8, we prefer to write it down at the end. So that means I pull up this term in the front. So the A is in front of the cosine. So make the one so the denominator in the front become an A. That means 1/8 times cosine 4x, and then plus the D. So plus 7/8. So this is the final answer. It takes a little while, but it's not very hard. Just use the formula we just learned. Okay, let's see. Okay, no. Let's see, graph this one. So you see, we have learned that if we graph something, we need to have y equals a times sine or cosine. For example, if cosine, so we have bx minus c plus d. But we have two terms here. How to draw the graph the function? We can combine them together to make them for one trig function. So pull out the coefficient 6 cosine x squared minus sine x squared. So it's very familiar for us because inside term is cosine 2x, 6 times cosine 2x. So this time we convert to the expression 2. This term we're familiar about. We just list some steps to graph it. But first we find the A equals 6. So the absolute value of A is 6. That's the amplitude. Decide the maximum and minimum value. Second one, the phase shift. There's no C term, right? It's just only 2x. That means the phase shift is 0. Or I just write down 0 because that means starting point is starting at 0 for one full cycle. Third one, the vertical shift. Vertical shift means D. There's no D. No. Or just NA. It doesn't matter. Okay. So fourth, find one full cycle. So we have learned that this is cosine function. Cosine is starting here. So got more starting here and then going down here. That means right here 0 to right. That means set 2x between 0 and 2 pi. That means 2x is greater than or equal to 0 and less than or equal to 2 pi. And thus solve the x. X is greater than or equal to 0 and less than equal to pi. Just divided by 2 for these three terms. So the starting point and the point for one full cycle. And what else? So actually we are just graphing the picture. We don't need to find the domain and range. So that's enough information. And then we can just draw a table with list x here and y equals 6 times cosine 2x. Make it beautiful. Y equals 6 times cosine 2x. And the first point is 0. What's the second point? What's the third point? What's the fourth and last? What's this pi? So we can divide 0 to pi into 4 parts. The middle one is pi over 2. And here is the midway of 0 and the pi over 2 is pi over 4. So this one is 3 pi over 4. If you don't know how to find these points, you just list a starting point. And then starting point 0 plus 1/4 times the period. Period, oh, I forgot the period here. So don't forget the period. So let's add a period. If I say this is a fifth point, period equals 2 pi over b. B is 2, that means pi. So 1/4 pi, that's 0 plus 1/4 pi, that's pi over 4. And then based on this one, plus 1/4 pi, 1/4 period, that's pi over 2. And then based on this one, add pi over 4. And then we got the last point. So put the point x value here. Pi over 4, pi over 2, 3 pi over 4. So the value here, the first one, I can plug in the 0 here. And for this one is 6. And then the second one is 0. Is that 0? Yeah, that's 0. And then next point, what is that? Let's go down. Oh, that's -6. So just plug it in. I skip some steps. Plug it in the expression. Find the value of this. Go down, going up, going down. On this image, why I got this mistake? It confused me. Sorry. So the cosine function, this cycle is here to 6. It's a graph like this. That's the graph inverse function. So this is a full cycle from here to here. So that makes sense. Okay, let's continue finding the value for this point. That's 0. And then the maximum is 6. Right now I find the 6 function. The first one, x is 0, is here. And then last point is pi. Mu1 is pi over 2. Here is pi over 4. 3 pi over 4. And the first one is the maximum. Assume this is 6. And then asymptote is, amplitude is, A is 6. That means maximum 6, minimum 6. First point is a maximum. And then the x-intercept going down to here. This is -6. My pen has a button, so sometimes I suddenly click it, it will turn to another page. Okay, and next point is also the x-intercept. I come to here, and then here is the maximum. So this is a way how we graph it. So this is the way this question help you to do a review of graphing the trig functions. Okay, let's move on to verify this identity. Okay, so for me, I like to start from the left-hand side, and also the left-hand side is complex. It has 2 terms. Also, it has 4th power, and it has the 2x here. So how to make this term to the cosine 4x? Let's start from the right-hand side. So when I see this, how to reduce it? Reduce the power. So we can use the power reducing formula, but another one is easier to reduce the power. That's the conjugate function, the conjugate formula. That's a squared minus b squared equals a plus times a minus. So we reduce the square to the AD terms. That means I can reduce this into a lower power terms. So let's see, is that cosine 2x to the 4th power is the cosine 2x squared and squared minus sine 2x squared and squared. So this is A, this is B. So this one equals cosine squared 2x squared plus sine 2x squared, and then times cosine 2x squared minus sine 2x squared. And look at this term. Is that the Pythagorean theorem that equals 1? Yes. That's 1 times the second term. So do you feel it's very familiar? Yes. Because we have learned that and this one is 2x. That means times cosine 2 times 2x. Because here is single one x, and here must be 2 times x. So here is 2x. I need to use 2 times 2x. So this is 1 times cosine 4x. It's cosine 4x. That means left-hand side equals right-hand side. So we proved it. Okay. Okay, let's move on to see next question. Apply the half angle formula. So pause the video and use a scratch paper to practice all of these half angle formula. Actually, you will feel very familiar about this half angle formula because do you still remember the power reducing formula? For example, if I have sine theta squared, is that equals to 1 minus cosine 2 theta over 2. If I'm looking for only sine theta, does that mean sine theta equals plus or minus square root of 1 minus cosine 2 theta over 2? So look at the half angle formula. This is alpha over 2. This is alpha. This is theta. This is 2 theta. Is that means I just use I just replace the theta to alpha over 2. So here need to be 2 times alpha over 2. Is that means here is alpha? Because 2 times alpha over 2 is alpha. Okay, so we get the half angle formula. So even you know how to find the half angle formula from the power reducing formula, but still, if you can memorize the formula, it will save you time. You don't need to prove it or solving how to get the formula. So take some time to practice how to practice and just memorize this in your mind, and it will save your time when you are doing your homework and the quiz and the exam. Okay, so cosine alpha over 2, that's plus or minus 1 plus cosine alpha over 2. Sorry. Tangent alpha over 2, that's plus or minus square root of square root of 1 minus cosine alpha divided by 1 plus cosine alpha. And also this 2 is important. So memorize these 2 because we know that we find these 2 easily because I use sine over cosine and I got this term. But these 2 terms we don't use that often. But still, if you see the question have this term, so you must know this one equals tangent alpha over 2. And this one also equals tangent alpha over 2. Okay, so if if I have a question, cosecant of over 2, what is that? It's just equals 1 over the sine of over 2. So if they are asking this one, just do the reciprocal. And secant of over 2, that's 1 over cosine of over 2. And cotangent, that's a reciprocal tangent. So cotangent of over 2, that's the 1 over tangent of over 2. Okay, let's move on to see the question here. So find the exact value of cosine 157.5 degrees. So this angle, it has the decimals. It's very hard for us. But can we use the half angle formula to find some easy angle? Yeah, for sure. So what's the 2 times this? So for example, this is alpha. So 2 alpha is, so 2 times 147.5. What is that? Let me use a cheat sheet. Where is my cheat sheet? What is that? I lost it. Where is it? 0, 2, 5, 1, 3, 315 degrees. Degrees. So 315 is an easy angle. Why I say that? So here is 0. Here is 90 degrees. Here, I try to make it clean, 90. So this is 180 degrees. This is 270 degrees. So the 315 must be in the 4th quadrant. So from here to here. So what's the reference angle? That equals 360 degrees minus 315. That's 45 degrees. So 45 degrees is a special angle. We can easily find the trig values. So right now we have learned that the angle, we double the 157.5. That's 315 degrees, and also its reference angle is 45. So we can find the trig functions. Let's copy down the question. That's cosine 157.5 degrees. So we should use the double angle formulas. Oh, so half angle formulas. Plus or minus 1 plus cosine 2 alpha. 2 times alpha is 315 degrees. And what is the value of cosine 215? So we keep a space for positive or negative, equals cosine 45 and ASTC. So here cosine is positive. That means it's positive 45. That means square root 2 over 2. So I can plug this value in the expression here. And it's positive or negative. You can't watch to say this is positive or negative from expression here. But we have learned that 157.5 is in the 2nd quadrant because here is 90 degrees. This is 180 degrees. It should be in the 2nd quadrant. ASTC. This is cosine. In the 2nd quadrant is negative. So here we keep the negative sign here. And then plug in the value of square root of 2 over 2. 1 plus square root 2 over 2 over 2. And then let's simplify this. So combine these two terms, 2. So this is become 2 over 2. That's 2 plus square root 2 And divided by 2, that means multiply 1 over 2. That means negative 4, 2 plus square root 2. And then 2 can be pulled out because square root of 4 can be pulled out from the square root because 4 is 2 times 2 is 2 squared equals negative 2. Bottom is 2 plus square root of 2. So this is the final answer for this question. Okay, let's move on to next one. Is that the last one? No, we have 3 more questions. Let's see this one. So the given information is sine alpha is negative 4 over 5. Alpha is between pi and 3 pi over 2. So the alpha is between, this is 3 pi over 2. Alpha is here. So remember that alpha is here. How about sine alpha over 2? So we use the half angle formula. So sine alpha over 2 equals square root of 1 minus cosine 2 times alpha over 2 is cosine alpha. So we only know the sine alpha, we don't know cosine, but we have learned that. So let me leave a space here. So just to say, how to find cosine alpha? Sine alpha is negative 4 over 5, and it's in third quadrant. And also we have learned sine alpha equals y over r. We can assume that y equals negative 4. R equals 5 because r is always positive. So y is negative 4. Can we find x? X equals square root of r squared minus y squared. That's 5 squared minus negative 4 squared. That's 9. That's 9. So square root of 9 is 3. It's positive or negative in the third quadrant. Here is negative. So we have the x, y, and r. Cosine alpha is x over r. That's negative 3 over 5. This is not a hard one because r is just a 5. Okay, so we know the cosine alpha and plug it in the equation. Sine alpha over 2 equals plus or minus 1 minus negative sign, negative 3 over 5. That means 1 plus 3 over 5 over 2. Okay, equals plus or minus. So combine these two terms. Bottom is 5. So 5 plus 3 is 8. 8 over 5 over 2. So this term times 1 over 2. That's plus or minus square root of 4 over 5. That's plus or minus square root 2. Oh, sorry. That's 2 over square root of 5. That's 2 over square root of 5. We can rationalize that. But what is the sign for the sine alpha over 2? We have learned that alpha is between pi and 3 pi over 2. So what is the alpha over 2? If that means divide these 3 expressions by 2, that means pi over 2. This one is 3 pi over 4 because divided by 2 and then divided by another 2. That's between, so draw a xy plane. So here is pi over 2. Here is pi over 2. And where is 3 power over 4? It's here. That means the angle alpha over 2 is here in the second quadrant. For the sine in the second quadrant is positive or negative? A, S, T, C. Sine is positive. So this is positive. And then rationalize this expression. This one equals 2 square root of 5 over 5. Okay, this is the way we find the sine alpha over 2. And how about the next term? Next term is cosine alpha over 2. So this one, we can also use the expression like this. And this one equals plus or minus square root of 1 plus cosine alpha. Because here is alpha over 2, here's alpha. And plug in the cosine alpha. Okay, before we continue, is positive or negative for cosine alpha over 2? So cosine alpha over 2 is in the second quadrant. So cosine angle in the second quadrant, that always be the negative. So keep the negative sign here. And then bring down the terms here. 1 plus cosine alpha. Cosine alpha is negative 3 over 5. So here is minus 3 over 5 divided by 2. So combine these two terms. Negative. That's 5 over 5 or minus 3 over 5. That's 2 over 5 divided by 2. That's negative 1 over 5. That's negative square root of 5 over 5. So this one is negative 1 over square root of 5. So rationalize this term, we got this. This is the way we find the cosine alpha over 2. How about the tangent alpha over 2? So if you use this one, it's okay. 1 minus cosine alpha over 1 plus cosine alpha. Can we use a simple one? So it has a square root. So can we use sine alpha over 1 plus cosine alpha? Or can we use 1 minus cosine alpha divided by sine alpha? So because it's easier, it doesn't have a square root and plus or minus sign here. So if you are not sure about that, go back to check here and there. Okay. Oh my goodness, how to delete these squares? Okay, continue. Okay, I just pick one. So pick one, the first formula, the sine alpha is negative 4 over 5 divided by 1 plus. So I should plus or minus because I need to find. Okay. I need to plus here, but here is minus negative 3 over 5. So minus 3 over 5. Then the top is 4 over 5. The bottom one is, so be careful, here is 3. Okay, so 5 minus 3, 5 over 5 minus 3 over 5 is as 2 over 5. And then let's simplify this. That's negative 4 over 5 multiplied by the reflection of this 5 over 2. That's negative 2. So let's work if we use this formula or this formula. If we use this, so you still need to do the square root and also decide the plus or minus sign here. Okay, let's move on to see this one. So this one, the first I will know that the inverse is always an angle. I just say this is alpha, and just let cosine, the inverse cosine 1 over 5 equals alpha, and then looking for what? Looking for sine alpha over 2. So do you still remember the formula of this? That's plus or minus square root of 1 minus cosine alpha over 2. Okay, let's see. So I can convert this into the regular form. That's cosine alpha equals 1 over 5. We have learned for the cosine alpha is from here. Oh, so the inverse of cosine alpha, the angle can be from 0 to pi. And this one is positive because ASTC. Cosine here is negative. Cosine must be here. So alpha is in the first quadrant. And so how about so alpha is between 0 and pi over 2 in the first quadrant because the angle is positive. The trig functions of alpha is positive, is in the first quadrant. Alpha is between this. How about alpha over 2? Pi over 4. That's still in the first quadrant. Is here. Okay, if that means every trig function's value is positive in this quadrant, that means here we only keep the positive sign for the sine alpha over 2. So 1 minus cosine alpha over 2. Okay, so we have the cosine alpha. We also have the expression for sine alpha over 2. So that means sine alpha over 2 equals square root of 1 minus cosine alpha over 2. So I can erase this because I just move it to the middle. Okay, this one equals square root of 1 minus 1 over 5 over 2. So the top one is 1 minus 1 over 5 is 4 over 5 over 2. That means square root of 4 over 5 times 1/2. Then equals square root of 2 over 5. So this one equals what is that? That's 5. Square root of 2 times square root of 2 of 5. That's equals square root of 10 over 5. So this is the final answer. Let me save it. Okay. This is the last one. Let's see the last one. So I prefer to start from the left-hand side. So you can do either way, but the left-hand side has 2 terms. It's complex. So left-hand side is what? I better don't use equal sign. So it's this. So this is x over 6, x over 6. This is x over 3. Is that means x alpha over 2 and alpha? The relationship is alpha over 2 and alpha? Yes. So that means I can convert this one to one expression. I prefer 1 minus cosine 2 alpha. Oh, sorry. Alpha. That means 2 times this term. 2 times pi x over 6, that's x over 3. Divided by sine x over 3 sine 2 times x over 6 plus. Why I do this? Because if I use tangent, for example, if I use other formulas, it has plus or minus symbol. So tangent alpha over 2 equals plus or minus 1 minus cosine alpha or 1 plus cosine alpha. So it has square root. I also have plus or minus sign. So we don't use this one. How about cotangent x over 6? So we know that cotangent equals the reciprocal of tangent. That means I can do the reciprocal of this. But have a think about another formula. That is tangent alpha over 2 equals sine alpha over 1 plus cosine alpha. So if I flip this one, the bottom have the same x sine x over 3 terms. It's easier for us. So I pick this one. I flip this one, so cotangent. So the bottom is sine 2 times x over 6. X right now is x over 3. And the bottom is 1 plus cosine 2 times x over 6 is x over 3. And then they have the same, oh, I forgot, here's 3. Okay, they have the same bottom. That means sine x over 3 in the bottom, add the tops together. 1 plus 1 is 2. Minus cosine x over 3 plus cosine x over 3, that's 0. So I can make the line shorter, but it's fine. So 2 over sine x over 3. So the reciprocal, 1 over sine x over 3, is that the cosecant x over 3 reciprocal of this? Yes. So right hand side equals left hand side equals right hand side. We proved this identity or this equation. So that's no. Okay. Let me save it. So that's the way we prove this question. Okay, that's the end of the this lecture. If you have any question, please let me know. Okay, have a good one.